Welcome to this Think Small Cell webinar, where today we'll be talking about scaling the small cell deployment numbers from relatively few today to thousands or tens of thousands, and discussing why some of the current processes and tools behind that are perhaps inadequate. Before I introduce our speaker, I'd just like to clarify the structure of the session today. Will be a presentation from our main speaker, during which there will be one or two interactive audience polls, followed by a question and answer session. If at any time during the presentation you'd like to post a question, you can do so with the control panel on your screen and we'll review all of the questions submitted and present those that we have time for at the end. The slides from the session today will be posted and made available within 24 hours, and all of the people who've registered and attended the webinar will be sent an email with a link to that. So without further ado, I'd like to hand over to our speaker today, Phil Bull, the Solutions Marketing Manager in Amdocs OSS division. Over to you.
Okay, thank you very much, David, and good afternoon and good morning to everyone. Small cells have been really a major topic in the industry over the last couple of years, but it is only now that service providers are starting to plan their mass deployment and are beginning to realize some of the challenges and limitations that they have with their current planning tools and processes. So let's take a look then at the agenda. Just need to go back one. We have a little delay here. So I'm going to start off just touching on the small cells market and what the changes are going on in the market today, why there is apparently still a bit of a delay before the mass deployment of small cells actually takes place. I'll talk about the deployment challenges, and particularly around the backhaul complexity. There's an area here which we need to look at in terms of why it's more complex to roll out small cells as opposed to macro cell rollout. Then I'll take a look at the limitation of today's planning tools and processes, and then I'll go on to introduce to you the Amdocs small cell solution and our approach to process automation using what we call catalog-driven factory approach. Then I will go through some of the benefits of what we call dynamic plan management. I'll explain what that is a little later on. And then I'll summarize, and then we'll go into a Q&A session at the end. So let's just have a recap on what small cells are before we start looking at the tools and processes. So small cells are essentially small cellular base stations designed to provide targeted capacity and coverage to improve the user experience. So they operate in the licensed spectrum, they use mobile technology. They're really designed to work with internet-grade backhaul in order to be able to keep costs down and make the business case work for small cells. There are quite a wide range of small cells, and in the context of this presentation, we really want to be talking about the public access small cells. So we're not really talking about femtocells, which tend to be residential, enterprise indoor, but we're looking more at the metro cells. These are targeting the urban streets and high density areas such as shopping malls and railway stations, for example. And also there are the rural small cells which are used to provide capacity and coverage out in the far-reaching sort of remote small villages and towns. So just taking a look then at the public access small cells market. despite the analysts' predictions, or all of our predictions really, about the small cell market really taking off over the last year, it's only just now that we're seeing the small cell market emerging in many countries. We've seen over 60 trials completed to date, and there's no doubt about it, the small cells growth is on the way. So it's a situation where we know it's going to happen, it's just a case of when. And small cells, well, there's little alternative to small cells. Of course, we can deploy more macro cells to get the coverage, but that is more expensive, it's not so targeted, and small cells is a really great solution which complements the macro cell deployment today. So if we look at the Moore's technology adoption life cycle curve, I'm sure you're all familiar with the crossing the chasm, and this particular example here relates quite well to the small cell situation. We think that most of the operators today sit in the early adopters stage of this life cycle, and they have a number of challenges to cross that chasm into the early majority phase. Those challenges are around the delays in some of the technology. For example, chipsets have only now just become mature enough and cheap enough to be adopted on mass deployment of public access small cells. And also there's a lack of suitable tools and processes, as we see it today, to allow the operators to be able to move quickly and deploy very large numbers of small cells. So what are the challenges that operators are facing? Well, first of all, operators just can't keep up with the rapid introduction of new technology while they're trying to expand their network capacity. And one of the biggest problems with small cells is actually the complexity of the network. Now, that might not seem apparent to begin with, but we'll talk in a minute about that complexity and where it comes from in terms of the number of different backhaul technologies and possible permutations that you can have to deploy a small cell network. And apart from the complexity, there's the sheer volume of tasks to be carried out. There's huge numbers of projects to be managed. Some operators are planning to roll out thousands of small cells per month. That's they have to manage hundreds of related projects across hundreds or even thousands of people, and they need to be able to deal with lower cost, lower skilled human resources to be able to install that equipment cost effectively. So apart from the volume and complexity, they're also faced with a lack of automation in their tools and processes, and they need to be able to deploy those small cells cost effectively to meet the return on investment targets. So let's go into our first poll question. So they should be coming up on your screen now. Right, thank you. So the question is, which do you think is the biggest challenge for operators deploying small cells? Out of those areas that I talked about just now, is it network and project complexity? Is it the high volumes of small cells that need to be deployed? Is it about the outdated tools and processes, or do you think it's more to do with cost and time to deploy? Which is, out of those, the most challenging? Please, can you make a selection now? Okay, we're just waiting for the poll results to come in. Okay, so here are the results. the majority of you feel that it's about the network and project complexity, which is the biggest challenge. And actually that's really interesting, because we see that also as being a particular challenge. How do you overcome that you know, network complexity? How do you deal with all the variations in the design and deployment of the network, and how do you do it quickly and efficiently? We've got even results on the other three, so that is quite interesting. So thank you, David. Can we move on to the next slide? So I talked about the complexity, and where does that complexity actually come from? Well, we know that much of it is in the backhaul, and there are many different backhaul permutations, technologies, different types of deployment options. And here's just a few examples. So for example, the operator may be deploying their own fiber, or they may be outsourcing the fiber connection back to the core network. And that's actually the piece of network that takes you as far as the point of presence. So that point of presence is likely to be in the metro areas, at the periphery of existing networks. So if you're talking about broadband, reutilizing existing broadband infrastructure, then those points of presence may be close, but not ideally located right by your small cell where you actually want to deploy it. So there's that last mile, or last a few hundred meters, that needs to be taken care of. And that last connection can be either more fiber, so that could be fiber in the ground or fiber over poles, connecting your point of presence out to the particular street, and maybe daisy chaining the cells, small cells along that street. Or it may be that you might choose to use a wireless connection, and that wireless connection, there are many variations. You can have line of sight, non-line of sight. You can have point-to-point, point-to-multi-point, and so on. So there are many different options, even in the last few hundred meters of connectivity using wireless. And you may want to deploy a wireless hub to distribute or connect to a cluster of small cells. And they could be indoor or outdoor small cells. So here again, there's many different permutations. And then finally, the last example here is with a rural small cell example. There might be a need to make that long haul connection, if you like, the backhaul connection over a satellite link, because that might be a deployment in a small village or remote location that simply doesn't already have internet network available. And the only cost-effective way to do that would be to provide a satellite link, and then maybe a wireless point-to-point connection at the very last few hundred meters. So there we have a number of different permutations, and that leads to the complexity of how do you select the technology, how do you design that that backhaul service. Do you outsource? Do you build your own? There are so many different decision points that need to be made really quickly, because you need to be very efficient at being able to roll out those hundreds or thousands of small cells. Now, looking at the end-to-end process, if you look at the main process flow in the middle of this diagram, you see a typical rollout plan. You have the initial project creation, an initiation of the project. You may have a plan of demand system driving into this to provide information about where to place your small cells, for example. And then you've got the process running through planning, design, construction, and optimization. And of course, what you really need is to be able to manage that whole process end to end across all the different organizational groups within the not only within your in the operator's domain, but also outside as well. So third-party partner management, for example. So we have different organizational groups, such as the project management. We have sites and estates. We have finance, planning, design, and the construction teams, of course, in the field. So all of this leads to a need to have very tightly coupled and well processed end-to-end orchestration, where everyone can share not only the same process but also share the same information, and that is often where the problems start. So the traditional approach to managing workflow, life starts off simply. You have a plan that could be quite a well-designed plan, but over time there are going to be changes. There are going to be duplicate processes to handle, to deal with the variations required. There are going to be a number of different access options, different aggregation options, venue-specific options, and so on and so on. So what starts out as a fairly straightforward fixed plan starts to become much more of a problem over time, and may end up becoming like a bowl of spaghetti here. And the impact to the business is that evolution then becomes painfully slow. You have to implement many workarounds. You have many manual steps in the process. Documentation starts to fall by the wayside, so you get undocumented processes. You get quite a lot more swivel chair, and that means guys working between multiple systems and having to transfer manually information from one to the other. You end up having to utilize more highly skilled tasks and apply more highly skilled people to those tasks, because you have to have people to be able to resolve the problems that are going to start to evolve. So the whole thing really it becomes problematic. And we see the limitations of today's planning tools and processes mainly around the lack of this end-to-end orchestration across multiple systems and organizational groups. And we also have heard from operators that it's difficult to scale effectively their existing tools across tens or thousands of tens of thousands, I mean, of small cells. It's a real challenge to start to scale up very large numbers of projects. And there's a lack of agility to handle in-flight project changes. So, for example, if a field guy goes out on site and finds that he can't connect up the small cell to a particular power supply because that particular supply is not available, it hasn't been installed, or it's the wrong voltage or something, and he has to then make a quick decision: what alternatives does he have in order to be able to get power to that small cell? And so you need to be able to go back and retrospectively change the plan and the process in order to be able to accommodate those changes. And then there's a lack of centralized information around the network resources. And this is what we call a single source of truth. You really need to have information held in a central repository that can be shared among all those different organizational groups, individual people, and having one source of information that is directly synchronized with the actual network and with the actual deployment, and so it isn't information that is actually, out of sync with the reality of the outside world. And then there's a lack of integrated technical design, and this is a particularly challenging problem. How do you get your technical design closely connected to process? How do you actually have it relating to the plan and the deployment process? They're often completely separated today, and that is a real challenge in itself. So what are the business impacts as a result of those things? Well, first of all, there are higher project costs incurred, things take longer, projects are delayed. The quality of the deployed network may well be impaired because people we cut corners and don't follow process and procedures. You might end up with more truck rolls, more site visits. You may have lost accountability. So individuals, it's difficult to trace who actually was responsible for a particular set of actions and changes, for example, in the network or in the design. And of course, there's a need for higher skills, which increases the cost and the overhead and having to train people up and so on. And in the end of all this, it's difficult to meet those large numbers that I mentioned earlier in terms of the volume of small cells. So let me introduce to you now the Amdocs small cell solution. This is a solution which provides a complete end-to-end catalog-driven planning, design, and rollout solution for next generation networks. It's an automated planning and project management tool that reduces the costs and speeds up planning and deployment of mobile and fixed networks. So it's not only about the small cells, but it's also about the backhaul and how to connect those up, how to manage the Ethernet connection across the backhaul, and it can be applied to other networks as well. It reduces the deployment costs by up to 25% on average, and it can reduce the network design time by more than 30%. It manages the very large numbers of projects, so it's highly scalable and can deal with rapid deployment. It increases the project efficiency and enables your teams to work much more effectively. And it's multi-technology. It supports lots of different types of network technology and multi-vendor, so it works across all vendor equipment. So let's take a look at a little bit more in detail at what we mean by automating the rollout process and where this solution fits in. We've got along the bottom of this diagram that process, end-to-end process for the deployment of the small cells, and overarching that we have the plan and design piece. So this is the small cell solution, which is the dynamic process and project management tool, and this is a tool which utilizes a catalog driven approach to process automation, and I'll talk about that in a little bit more detail in a minute. It provides guided user tasks for individuals. It manages network and human resources. It automates the resource leveling as an option, and it can deal with third-party partner management and so on. And quite importantly, we aren't replacing BPM tools here. We are actually enhancing BPM. So this is a solution which is like a smart layer of orchestration which sits on the top of BPM. It utilizes BPM, and so it's not a replacement. It's actually something which provides that complete end-to-end process automation piece. And as its inputs, it takes input from the plan of demand systems, and in this case we have also a solution called Smart Cell Placement, which is a solution that allows you to identify where to locate your small cells. It identifies the coverage not spots and capacity hotspots. It identifies where your high value VIP users are and their churn propensity and so on. So the idea here is to use business intelligence analytics to gather information from a number of different sources. So those could be drive test information, they could be radio access network data, it could be financial data relating to customer costs and account information. And that information then gets correlated together, and the result is a list of prioritized small cell sites that need to be addressed in a prioritized order. So essentially, it provides that list of which sites you need to deploy your small cells first in order to make the best return on investment for those small cells. So that's just a little bit about that front-end automation piece. And then we, as I say, we manage that process all the way through the plan, and we provide for field deployment guys, we provide guided field force tasks. And these are applications that run on mobile devices such as mobile smartphones and tablets. And we provide guided user tasks here to instruct the users what to do, where to pick up the small cells, where to drive to, where the site is. We provide a lot of centralized information about what to do when you get to the site, what safety equipment to take with you, how to install it, and how to configure and turn up the device, all from the mobile device. So the small cell can be connected and then activated using this approach. It can also include things like barcode and RFID tagging, which allows the field guys to scan in the barcode on the equipment and log it into the asset database, or make sure that they're tracking the location and the status of the asset. And all this information then gets passed back up into the centralized repository I talked about earlier, the inventory and site database. And that's kept alive with the current information. So there's a little bit of delay between the slides. Let's take a look then at what I mean by a catalog-driven factory approach. So what the system does is it takes in a set of network and project profile requirements, and it breaks down those requirements, and they come from the plan of demand system, by the way. It breaks down those requirements into component blocks, and we have stored in a catalog predefined project flow blocks. These are the little blocks of the project plan that you can see there, together with the network design blocks. These are small component blocks of the actual network design. And because, as I said earlier, there's some complexity in the backhaul, you may have a mix and match of different technologies to extend the backhaul right through from end to end. What we do here is the system will automatically generate the plan dynamically for every single individual small cell. And not only that, but it generates the design as well. And that design can run through stages of approval. It can run through technical feasibility and so on. And because we use this building block approach, we can reorder different designs depending on what requirements, what the requirements are for the particular small cell network. We call this approach design once, deploy many times. So you reutilize these design blocks, these building blocks, and they can be added over time. You can have more blocks added to the catalog. So let's talk a little bit about dynamic plan management for a moment. When I say dynamic plan management, what I mean is that the plan is not only automatically generated from the set of requirements on demand, and when the planner actually needs to create and execute the plan, but it's it's a very versatile and agile and flexible approach. It's highly repeatable, and it's much easier to maintain because there are sets of plan templates for different types of small cell stored in the catalogue, and we have these building blocks as I was talking about, and the plan building blocks can be easily edited in BPEL and created using existing editing tools. And this is where it links very closely to BPM, as I said earlier. And so the whole approach here is a lot more flexible and can accommodate on-demand, in-flight project changes and workarounds without disrupting the rest of the project. So it's all about being flexible and being able to accommodate changes as quickly as possible. So what are the rewards then of an end-to-end process automation approach like this with these process tools? Well, first of all, it reduces the rollout costs through increased project efficiency. If your project can be more efficient, if you make more efficient use of your human resources, you can then reduce the costs to deploy. And it speeds up the time to market for small cells very significantly. It enables these large-scale projects to be deployed, so it scales across many thousands of small cells per month, and it limits the project risk and human error, which would normally creep in when you have changes to the plan, changes to the design that are difficult to maintain in other ways. So we're going to open with the next poll question. Question number 2. So where do you see end-to-end process automation having the greatest impact on the business? Is it around reducing the rollout cost through applying achieving greater efficiency? Is it speeding up time to market? Or is it enabling projects to scale over thousands of small cells? Or is it around the reduced human error and reducing the number of truck rolls? Please can you select one of those 4 options? We're just waiting for some of the results to come in. Okay, and here's the results. So interestingly enough, it's the rollout costs through greater efficiency is the main point here, and of course that you can see comes from the reduction of wasted time and effort through better project efficiency, utilizing the human resources more effectively. The other answers are quite interesting as well. So second is the enabling projects to scale over thousands of small cells. And in fact, yes, that is particularly an interesting aspect. That is one that we've been told is a challenge today. It's one thing to have a plan for a few tens of macro cell rollout projects, but when you come to hundreds or thousands of small cells, the whole problem gets a lot more complicated, and particularly, as I said, with the backhaul challenges as well. And then the third there is speeding up time to market, followed by reduced human error on the truck rolls. So that's thank you very much for responding to the poll question there. I'd just like to summarize, and I see we're a bit ahead of time, But that gives us a little bit more time for Q&A. So the key points to take away then are that we're seeing operators having a number of challenges in rolling out small cells. It's around the complexity and volume, the sheer volume of small cells that need to be rolled out. It's relating to the lack of automation, end-to-end process automation in the current tools that are being used. And it's about the cost of deployment. The operational, the OPEX cost particularly, is a challenge to keep down, and that usually comes about by cutting costs comes about by becoming more efficient. So current planning tools and processes we've been told are inadequate. Real Wireless ran some market research recently and asked 60 operators whether they felt that their current tools and processes were inadequate for rolling out small cells, and more than 50% said that in fact they felt that they needed to upgrade their tools and processes in order to be able to manage rolling out small cells. And that's because the current tools don't scale, they're inflexible, and they can't support the complex networks and projects that need to be supported with the small cell rollout. There's a need for agile end-to-end process automation across multiple systems as well as groups. So it's not just about having a process, but you need to be able to have that process managing and working across a number of different systems. So there is a degree of system integration to be done. It's better to have one single source of information and have multiple systems sharing that information. And of course, across multiple groups of people, you need all your operations and your planning people and so on all to be sharing common information about the project requirements, about the site information, about the network, and so on. And of course, those different pieces of information can be tailored through different views to different types of people, so that they get their own custom view into the database, into the information that they need. So Amdocs small cell solution then is a catalog-driven approach to process management, which helps to resolve the technical complexity and the scalability of rolling out small cells. So essentially, it cuts the time and cost for small cell deployment by up to 25%, and this is through increased project efficiency. So on that, that concludes my summary, and I would then like to go to an open Q&A.
Thanks,
So
thanks very much,
over
Phil.
to you, David.
So as Phil suggested, we're on to the Q&A session. We've had a few questions come in during the presentation, but do please submit questions on the control panel on your screen now. And what I'll do is just consolidate a few of them if we have similar themes from people. So before we go into one of the chunkier questions, a question from one or two people just asking if you could clarify this term BPM, which may not be familiar to everyone. What does that term mean, and what is a BPM tool?
Yeah, okay, David, thank you. So BPM is Business Process Management, and it is an approach to process automation and workflow that has been utilized in the industry now for a number of years. BPM, pardon me, BPM is not new, but what we are doing here is not replacing BPM. BPM is a best practice process management for orchestration across systems and people. And what we do is we reutilize BPM. Our small cell solution has APIs that allows it to connect to and interwork with existing BPM platforms. So those are things like IBM Lombardi or ActiveVOS, or many other different platforms that are available today. BPM requires workflow to be predefined and edited, and that workflow is defined in BPEL, which is Business Process Execution Language. And there are a number of tools available on the market to allow you to edit BPEL in order to be able to define those workflows. And in fact, those modules, those building blocks that I was talking about earlier, consist of small chunks of BPEL that can be predefined using those editing tools, and then they're stored in the catalog to be used as and when required by the system.
Thanks, Phil. Another question relates to field force tools, such as some of the apps you see on tablets and smartphones. If you already have those in use in the organization, can these be used, and how do they integrate with this process and project management system?
Mm-hmm. So very good question. Typically, many operators already have these field force tools. They come in various shapes and sizes, but typically now many of them are apps based. You know, you download essentially an app from an app store that has a specific function which can be deployed on a tablet or a smartphone. That function might be, for example, a guided task set of processes for particularly deploying small cells, or it could be a maintenance application. It could be an audit type application. There are many different types of application. Now, those field force tools will typically work into back office systems such as workforce management systems, WFM acronym. You may well have already these in your OSS, and again, we don't replace workforce management. We interwork with existing workforce management systems. Workforce management really is about people and process and availability. So it's about allocating the right people for the right jobs, having a database of human resources, and having the ability to assign tasks to people, those specific people who are perhaps in the field with those mobile apps that I talked about. So the API that you would typically have, the interface would be between a workforce management system and these remote field force tools, but also some of them can have a connection back into the inventory system as well. So they can, the field applications can take information directly from the inventory system. So, for example, you can get an update of exactly what is the status of the network, what types of equipment are in the network, what's the status on the card configuration, and so on, by just simply requesting that download from the inventory system.
Thanks, Phil. We've had 2 or 3 questions related to planning in different ways. So one question about the positioning and the placement of the small cells, which you did cover early on. Another one about how you choose and decide what the configuration of the small cell is, and a third one around capacity planning of the backhaul. So if you're routing presumably the connections from several small cells through the same hub, you'd have to ensure that you'd provisioned or assigned enough capacity to cater for traffic to all of them. Is this something to do with the scope of the deployment system you're talking about here, or would you see that being done by different systems that somehow interwork with this?
So I'll take those 3 points individually. So the positioning and placement of the small cells. I think this is typically a plan of demand type system, but when we talk about the placement, we really need to be sure about where to locate quite accurately the small cell in order to be able to get the best advantage from it. There's no point in deploying a small cell in the wrong location. It's just simply not going to generate effectively the revenue that you need from it. So when I spoke a little bit about our smart cell placement solution, that is an example of one of those tools that can be used to identify the best location for your small cells and to be able to order the small cell priority list, if you like, of which defines which sites and which cells to deploy first. And the information coming from that system will be imported into the planning and rollout tool. And this is the Amdocs small cell solution. And information will pertain to things like the geographic location, so where the site is, where the specific small cell needs to be deployed. It can have information about the configuration requirements as well. So you can link this to radio planning as well, so that you get radio configuration data. Things like positioning, being able to angle the small cell at the correct pitch and azimuth. You can set the right height from the ground, you know which direction it should point in. And the radio configuration can be, for example, it might be a multi-mode small cell, so it could be 3G or 4G LTE. It could even include Wi-Fi as well. So this would really define what parameters to set up, and many of those parameters, by the way, can be pushed down automatically from the system to the small cell, so that field staff, all they have to do is say, I've connected it, my backhaul's connected, now start the configuration process. The small cell will be discovered automatically, communication will start with it, and then there'll be a set of configuration information which is then downloaded to the small cell to tell it what to be, and how to behave, as it were. And then finally, capacity planning of the backhaul. That is very much down to this network planning and design piece, which I was talking about earlier. So it relates to the building block approach to the backhaul configuration. But what we have to do is identify the requirements versus what is already out there. So what we can do is we can match up the set of requirements for the capacity required on the backhaul, and that might be relating to a cluster of small cells. Let's say there are 10 small cells out at the street level, and they get aggregated back through a hub and back through the existing broadband network. And what you need to know is, well, first of all, is that broadband network going to have the capacity to support that cluster of small cells? And secondly, what do I need to do in order to configure the network elements? And again, as much of that as we can be automated, and we utilize the planning functions that work with the inventory and with the network configuration components to be able to do that.
And a very quick sort of yes or no, Phil, one or two questions relating to SON and whether that configuration of the small cell, as you said, that automation, that would be done externally by a SON system that would interwork with your solution.
Absolutely. So both centralized SON and distributed SON can be utilized, and in fact, many small cells now are being designed to support SON. So they will do things like automatic neighbor relation configuration through using SON functionality. Yeah, definitely.
Okay. On a slightly different topic, you did make some bold claims about the level of improvement and value of the system. Are there any management dashboards or reporting against particular KPIs that just prove how well the process and the system's running? And what sort of KPIs would you expect to be of most importance?
So there are several key KPIs which we gather, and incidentally we do support web reporting and management dashboards in the solution. But typical kinds of KPIs are in terms of, for example, the deployment time and planning time for the transport, the actual time for deploying the small cell once the site has been approved and the small cell deployment phase has started. So each of those phases, in fact, on that end-to-end process diagram I was talking about, you can set up KPIs to measure the actual time it takes to go through each of those phases, and then you can average out those times to get aggregate results. So the interesting thing there would be to set targets and then to measure the actual, and then gradually what you'll see ideally is those actual measurements start to move in towards the target, so you close the gap effectively. Now that gap can be closed either by some tweaks to the system in terms of process, but it's also about people learning and getting more used to the process and working out the most efficient way of doing things. And so it's a human learning process as well, but you can monitor and manage that more effectively by having the ability to track KPIs.
Thanks, Phil. I think we've got time just for one or at most two more points. One question relates to third-party subcontractors or partners. How does the system work with the third parties that might actually be outsourced to install these systems? And I guess that would mean is there a particular borderline or where the functions are divided, or can that work in different ways?
Yeah, so I think that can really work in different ways. So the way in which we have implemented it already is to provide an API to third parties third-party systems that allow them to have information relating to the demand. For example, if you take a build contractor, the build contractor for the backhaul will need to know what the plan of demand is and what the requirement is for each of the backhaul services and circuits. So you can have different degrees of interaction, and you can expose as much or as little data to them as you like. But essentially, it's about giving enough information to allow the third-party contractors or suppliers, and it can be, for example, the suppliers of that broadband network services that I talked about earlier. And at that point, you can even provide some form of brokerage interface, a web broker that allows both the service provider to go out and look and find out what services are available and where those points of presence are before they actually purchase the service. So they could be looking across multiple providers, and vice versa. The providers of that service could be looking in to see what are the requirements from them for those backhaul services.
Thanks very much, Phil. I think we're running out of time now. So what I'd like to do is really just to ask you if you have any closing thoughts before we wrap up the webinar.
Okay, David, well, thanks for that. So I think there's no doubt about it that small cells are set to grow massively over the next few years, and that service providers need to be armed with the right tools and processes to meet that demand for rolling out thousands of small cells. And they need to take an end-to-end view of process orchestration. I think that's really essential. If you don't do that, then you're going to be approaching it piecemeal and be very inefficient. Just as a closing remark, I'd like to invite anyone who's interested to learn more about our Amdocs small cell solutions to either contact me or to visit our website, which is on the last slide, which in fact my computer has just decided
It's
to.
it's just being displayed now.
Okay, great. Okay, so if you like to visit our website there, the website address is there, or contact me, Phil Bull, at Amdocs.
And with that, that terminates our webinar today. Thank you very much indeed for watching.